Okay, today I'm going to show you how to solve linear equations by substitution. So there's going to be, we've done graphing and you're going to see another way. But what this one is different, if you look at the example I'm going to show you that's already worked out, and then we're going to actually work through some. There's one where there's one of the letters in the two equations, in this case the y, that is isolated. It's the only thing on one of the sides of the equal sign. So y is equal to 3x minus 2 in this case. I look at the second equation and it has an x, a y on the left side, so nothing's isolated. So what I do is I take that information there, that y equals 3x minus 2, and everywhere I see y in the second equation, I'm going to replace it with this 3x minus 2. Now, sometimes I call it a blob. I take the blob, I stick the blob in. But whenever I stick a blob in, I always put parentheses around it, just because it seems to me that it reminds us that if there is a distribution that has to take place, that we don't forget it. So here we have 3x minus 2, and it's in the parentheses because instead of 2x, the minus, the 3, y, substitution, 3x minus 2 equals negative 8. So everything stays the same except the y. Now I go ahead, and you remember if you looked at one of my previous videos to try to remind you, is we start with distribute, combine, on the same side, finish the problem on the variable side. So that helps me remember that the first thing I need to do is distribute. And I'm going to distribute here with the negative 3. I know some people accidentally just distribute the 3, but whatever's in front of it, that also is counted toward. So it's going to go negative 3 times 3x and negative 3 times negative 2. So that would make this a negative 9x, but I write it as minus 9x. Remember, minus and negative, they mean the same thing. And negative 3 times a negative 2 is a positive 6. So I've distributed. My next thing to do is combine if there's something to combine. Now, the 2x minus 9x, we can just read that left to right because they're on the same side of the equal sign. So 2x minus 9x gives you a negative 7x. Bring down your plus 6. Bring down your equals. Bring down your negative 8. Now, there's no variable on the other side, so we can just finish the problem on the variable side. What that means is here's the variable. It's on the left side of the equal sign. We're going to get rid of all of the numbers on the left side of the equal sign. And we start with the constant. So to get rid of a positive 6, we subtract 6. I subtract 6 on this side. Now, if you haven't heard me mention this before, I like to call this touch math. If I can touch it, I can push the button on a calculator. Again, I'm a big fan of mental math, but we also know that some of you doubt yourselves. So it's negative 8 minus 6. 4 things to touch, 4 buttons to push, and that'll give you a negative 14. Bring down my negative 7x. Negative 7 next to the x simply means that it's being multiplied, so I will divide. I divide by negative 7 because my goal is to get a positive 1. So I divide by negative 7 on this side. I'm left with x equals 2. Now that's my first numeric value. You see that? So x equals positive 2. Now, remembering what a solution to a system is typically an ordered pair. So when we're solving this, now we put it back in. And if you see my big old arrow here, we're actually going to shove it right back in to this top one, y equals 3x minus 2. So I'm going to show it down here. So y equals 3, and again, I like to put parentheses when I substitute it in. 3 times 2 minus 2. So 3 times 2 is 6, minus 2 leaves me with 4. So we are left with y equals 4. So I have to remind myself that my ordered pair, it doesn't matter the order I find my answers in, but it does matter the order I put them in. So it's 2, 4. Okay, and that is my solution. Now, I'm going to also show you a couple times where it doesn't come out so nice. Okay, so in this one, what I'm going to show you, you have none of the letters are by themselves to start with. You have 2x plus y equals -1. So this one's going to have to be rearranged because I need a variable that is alone on the left or right side of the equal sign. So here, y equals, what I like to do is I like to look, are any of my letters, the x in the first one, the x in the second, the y in the first, y in the second, are any of my letters without a visible coefficient? And I have noticed that the y does not have a number in front of it. Now, technically, it has a 1 in front of it. But a 1y is the same thing as a regular y. So I've decided I'm going to isolate that letter. So I'm going to get the other 2x away by subtracting it. I want it completely gone. So minus 2x minus 2x. Only problem is, guess what? You cannot combine -1 and -2x because this has an x, this doesn't. So when they're not like terms, you simply just write them next to each other. Now again, if you look, you got your -1 minus 2x, and that's everywhere I see y. So I'm going to go back, not into the same equation I took this from, but into the second equation. So I have 4x plus 3. Don't forget, I like those parentheses. And now we are going to finish the problem. So we're going to distribute. So when I say 3 times that, so I'll bring down my 4x because that doesn't change. I make this a -3 because 3 times -1. 3 times -2x is -6x. Again, I distributed that all the way in, and it equals 3. I can combine, and again, the only things that are like term are the 4x and the -6x. Since they're on the same side of the equal sign, what I'm going to do is just read it left to right. So 4 minus 6 would be a -2x. And if you're doing touch math, I can touch a 4, I can touch a negative and a 6. But I don't ever say 4 -6, I would say 4 minus 6. I still have a -3 on the left, and I have a 3 on the right. Now I just have to finish the problem on the variable side. So the variable's on the left, so we're going to get rid of the numbers that are on the left. So here I will add 3 to both sides. That leaves me with -2x equals 6. Finally, to get rid of the coefficient that is attached to the x, we will divide by -2. And that leaves me with x equals -3. That is my first numeric answer. Okay, that means I get a number for a letter instead of up here where I had an expression. So what am I going to do? I'm going to plug that back in to my expression where I had y equals -1 minus 2x. Well, now I'm going to say y equals -1 minus 2. And what do I like to use? I like to use my parentheses. Parenthesis -3. And then when I put that in, I get y equals -1. -2 times -3 is a +6. I finally get a 5 as my number answer for y. All right. Now, I'm going to repeat that because it looks like I may have done all that without you guys getting to see it. So there we go. I plugged it in, put it through. Now, what do you think the ordered pair will be for my solution? The x comes first. -3, 5. Put it in a parenthesis. All right. Now, there's sometimes some scary things that happen, and I want to address those. Sometimes scary things happen. So I'm going to show you what happens. So here I have an x that's alone, 3y plus 5. So I've already got a blob started. So now, instead of plugging it in for y, I'm going to plug it in for x. So -2x, well, instead of x, what did I do? I put in my new blob, 3y plus 5, brought down my plus 6y equals 3. Now I'm going to multiply it in. Negative 2 times 3y is negative 6y minus 10 plus 6y equals 3. Now, look what happens when I go to combine. Uh-oh, negative 6y plus 6y, that's 0y. Minus 10 equals 3. Well, 0 times y is simply 0, so it ends up leaving me with negative 10 equals 3. That's not true. No way, Jose. So when that is never going to happen, it does not equal, we will say no solution. So if when you go to solve these, a letter cancels out completely and you're left with a false statement, the answer is no solution. Okay, and those, if you remember from the graph, will look like two parallel lines. Now, the other scary thing that can happen is what if a true statement is left? So here I have y equals 3x plus 2. I'm going to plug that in for the y value, 3x plus 2. And then I'm going to distribute. So I'm going to say 6x minus 6x plus 4. I'm sorry, look what I forgot. Negative 2 times 2, that'll be a negative 4, equals negative 4. Okay, I almost made a mistake there, which goes to show you it is very simple to make mistakes, even with a tiny little negative. So if you think for sure this should work and it's not, then you definitely want to go back and double check your work. 6x minus x is 0x. So now I have 0x minus 4 equals negative 4. The 0 takes away the x, so negative 4 equals negative 4. Well, that happens to be true. That is absolutely true. But it happens all the time. So what we're going to remember is that this is going to have a solution of infinitely many. Now, infinitely many, remember, is different. You actually have to write the words out. I have a lot of people who are like, is there a shortcut? Can I just write an infinity symbol? No, write infinitely many. If you keep being lazy, other people are going to pass you up. Okay, so anyway, make sure you substitute always into the correct variable. If you start with y and you have a blob, make sure you're plugging it into the y and not into the x. That's a common mistake people make. Okay.